Hi, here is a quick video to explain what is cert-discovery-venafi and how it can be used for TPP by TPP users. The first part of this video will be an explanation of what cert-discovery-venafi is, and in the second part I will show how to install it and what it looks like in TPP. So cert-discovery-venafi is very similar to the existing Venify PKI monitoring secrets engine for Venify HashiCorp vaults. If you have a vault and you want the certificates issued in this vault to appear in TPP, you'll want to use this plugin. But if you want to do the same for Kubernetes, and for example, you would like to see the certificates in your secrets to appear in TPP, then you're out of luck. What you could do is export all the secrets and then import them into TPP, but that's a manual task. So what cert-discovery-venafi is a controller that runs as a deployment inside your Kubernetes cluster. And given an access token and the right configuration to Venify TPP, it will push, or more exactly, import the certificate that is inside the TLS.crt key in your secrets into one zone or policy folder, as people call it. For example, here, I chose to have the policy folder Kubernetes, and that's where everything will be imported. One good thing about cert-discovery-venafi is that it immediately pushes the updates or renewals, and you don't have to wait. You immediately see the changes in TPP. So let's see, now that we have seen what it is meant to do, let's do a quick demo and install it and see what it looks like in TPP. We have a Helm chart ready to use. The images and charts are in a private registry, so you will need a JSON key. I already have one, and I'll create a Docker registry secret so that we can access, so that the pod can run. Now that this is done, let's log into the Helm, to the Docker registry that is hosting Helm chart. And finally, let's make sure we have one application API integration ready to be used. So I'll open Aperture in my Venify TPP instance. And I will use the vCert SDK existing application API. Let's make sure that the manage and discover options are ticked. And let's make sure my user is also can also access this integration. So as you can see, I'm going to use the JetStack platform user, which means that should work. Now let's close this. I will be installing everything in an OpenShift cluster 4.9 that I installed previously. And we'll be able to see everything from here. I'll select the right namespace. Okay, so this is ready. The next step is to set some variables. I will use them, the ones that I have in my history here. As you can see here, the zone I'll be using is Kubernetes. That you can see, okay, let's open TPP here. This is the policy I'll be using. It is empty right now. One tiny thing that I have done in this policy is that I disabled the enforcement of no reuse of private keys. This is important because some certificates may be renewed using the same private key, and we want to be catching these instead of the cert-discovery-venafi controller not being able to push the certificate. Let's go back there. We are done with the configuration. Let's create a token that our controller will use to talk to TPP, and let's put this in a token, in a secret. And finally, let's deploy using Helm. One thing I'll do right now is set the resources to a higher limit, because I have noticed that the default one, which is 20 megs, is not high enough, and because the number of secrets that are kept in memory in the controller is too high. So I'll put that to 100 megs just to be sure. And we should be set to go. Oops, wrong command. And at this point, the controller will start running, and we'll take a look at the logs so that we know what's going on behind the scenes. As you can see in the logs, we already have a couple of certificates being pushed. And if we refresh that, we'll see that they are pushed there in this policy folder. And for example, we can see the etcd CA certificate. And now let's refresh again. Yeah, we can see that some secrets cannot be pushed, and that's because they don't have, this one, for example, doesn't have a common name or a URI or an IP address or a DNS name. So it doesn't, the controller doesn't know which name to put here in this, the name that is over here on the object. And if we open Aperture, we'll be able to see the state of these new certificates. And one of them, for example, will be almost expiring. Okay, I need, yeah. So this one, for example, is almost expiring, and we wouldn't have caught this issue if we didn't have this this controller. So let's see other almost expired certificates. Yeah, most certificates in this Kubernetes cluster are short-lived, which means they appear in this expiring soon section. But yeah, that's how this controller works. And if one of the secrets gets updated, then we'll see what happens. I'll show you. For example, one of the certificates is renewed every minute, and we'll see that there is a history of this certificate that appears, and we have an issuer that renews every minute. For example, this cert called example cert that we see here, we'll see that the history gets updated as soon as the certificate gets renewed. And that's pretty nice. And we can see that this one has expired. One thing that would be nice also would be if every renewed certificate in this history should be revoked. That would be nice. Currently it doesn't do that, but yeah. So that's what cert-discovery-venafi does. And I hope you like this video.